Okay, so I normally have these available as a PDF. This one might be a little tricky to follow along just with the PDF, so I'm also going to make a video here. And our goal for this lesson is to be able to use synthetic division to divide polynomials. Of course, first let's take a look at the whole family here. All right, good old dad, which reminds us to divide, mom, which reminds us to multiply, sister, subtract, brother, bring down, and Rover, the dog, for repeat. Right, previously we had done this type of work with long division. Of course, the number on top gets to wear the hat. That's how I always used to describe it when I taught elementary school. So the top of the fraction, that's the number on top, that gets to wear the hat. So it goes inside the division symbol. Right, that is our dividend, our divisor, x plus 4, goes outside. And so now I got to concentrate and say, okay, how many times does x go into x to the third power? Right, I'm concentrating on that x, and I'm concentrating on that x to the third power, right? And I'm saying, hey, I know that x times x squared is going to make that x to the third. But then, of course, I have to multiply. And so x times x squared is x to the third. 4 times x squared is 4x squared. And now I got to remember I want to subtract. Right? And so when we subtract, we end up with a negative 2x squared, right? Positive 2x squared. Subtract 4x squared is negative 2x squared. And of course, the x to the third, subtract the x to the third, that just cancels out. So that's gone. Right, so now we're down to Rover repeat, right? We got to repeat the entire process. Right, we're down to repeat here. So of course, dad is divide. How many times does x divide into negative 2x squared? And so I'm thinking negative 2x. And then we get to mom, that's multiply. So I got to do x times negative 2x. And I got to do 4 times negative 2x. Get some of this extra ink out of here. And that gets me the negative 2x squared minus 8x. We come across to sister. Sister says subtract. And of course, when we subtract, since that's a perfect match, that's going to disappear, right? Negative 2x squared subtract negative 2x squared is 0. And then the slightly trickier part, negative 11x subtract negative 8x will leave us with negative 3x. Brother, bring down, so we bring down the next term, negative 12. And of course, we get to Rover the dog, we repeat the whole thing. Dad, for divide, we think it's going to divide in there negative 3 times. Mom, for multiply. Multiply it out. Sister, subtract. Hey, it's a perfect match, so it'll get 0. Brother, bring down. There's nothing to bring down. We're done. And then Rover does the double duty of reminding us to look for remainder. Well, there was no remainder. And so we just have x squared minus 2x minus 3. So that's what it would look like if we use long division, which is what we had been using. Now, the new twist today is we want to use something called synthetic division. And so if I'm looking at the numerator of the fraction on that previous question, right, if I'm looking at that polynomial, I say, I can think of that as a 1x to the third. We would normally never ever write it, nor would we say it that way. We just say x to the third. But I can think of the leading coefficient as being a 1, right? If I don't see a coefficient on x to the third, or I don't see a coefficient on x squared, or if I don't see a coefficient on x, I know it's a 1. And so I can also look at the denominator that we had previously, the x plus 4. I can set that equal to 0, and I can solve and say, hey, you know what? If x plus 4 is 0, x has to be negative 4. So to set up the synthetic division, I take the coefficients from that polynomial that I want to divide into, right? I got the 1, I've got the 2, I've got the negative 11, and then I've got that negative 12. All right, so I'm just taking the coefficients. Now, if you don't see that negative 12 as being a coefficient, remember what we really have is negative 12 x to the 0 power. So if that helps you make you think of it as a coefficient, normally we refer to it as a constant. But to set up synthetic division, I can think of it as being a coefficient of x to the 0 power. Now, if I'm trying to figure out if x plus 4 is a divisor, right, if that's a factor of this polynomial, I'm really asking myself, well, is negative 4 a root? Right, so if x plus 4 is going to be a divisor or a factor, negative 4 has to be a root or a solution. So I'm going to put down that negative 4, all right? So now here's how we do this. Drop. In other words, we're going to take that 1 and we're going to just drop it straight down. Multiply. So I'm going to take my negative 4, multiply it by 1. I get negative 4. Add. So I got to take neg 2 plus negative 4. I get negative 2. Multiply. Negative 4 times negative 2 is a positive 8. Add. Negative 11 plus 8 is negative 3. Multiply. So now I've got to take a look at the negative 4 times the negative 3 gets me a positive 12. Add. So I've got negative 12 added to 12. That gives me a 0. So you'll notice, except for the initial drop, it just becomes a pattern of multiply, add, multiply, add, multiply, add, and you just keep doing that until you get to the end. Now, something magical happened. We ended up with a 0 at the very end, right? I ended up with a 0. If we end up with a 0, that implies that there is no remainder, and therefore negative 4 is a root, and therefore x plus 4 has to be a factor. Now notice we just got the exact same answer with synthetic division. All right, that was 1 x squared minus 2x minus 3 with no remainder. All right, so we got the exact same answer that we had when we were using long division. So long division or synthetic division comes up with the exact same answer. Let's try one where we do not have it come out to be 0. Right, now again, if I'm looking at the numerator, I'm going to use the coefficients, but then on the denominator, I got to think, okay, if x minus 5 is the factor, positive 5 has to be the root. So from the numerator, I've got 1 x to the third, right? I got to think of, when I see that x to the third, I got to realize, hey, it's 1 x to the third. And so I'm going to use that 1. But then I see the 7x squared. So negative 7x squared, so I use a negative 7. See the plus 4x, so we use the 4. I see the plus 12, so we use the 12. And of course, if x minus 5 is the factor, we're checking to see if 5 is the root. So again, I can drop down that 1. Now I can multiply. 5 times 1 is 5. Now I can add. Negative 7 plus 5 is negative 2. Now we repeat the multiply-add process. 5 times negative 2 is negative 10. 4 plus negative 10 is negative 6. Again, let's multiply and add. 5 times negative 6 is negative 30. 12 plus negative 30 is negative 18. Uh-oh, that is not 0. Right? I did not end up with a 0 at the end. I ended up with a negative 18. So that's not 0. So there is a remainder. Bum, bum, bum. Right? We've got a remainder of negative 18. So therefore, 5 is not a root. Right? And therefore, x minus 5 is not a factor. Right? It did not divide in there evenly because I've got a remainder. And so to read the answer, that 1 tells me I've got 1x squared. Negative 2 tells me negative 2x. Minus 6 tells me minus 6. And then since the remainder is negative 18, I need negative 18 over x minus 5 because we're actually trying to divide by x minus 5. And again, if you're trying to figure out, well, how do I know that 1 told me 1x squared, right? How do I know the place value? I can either start back here as knowing that negative 6 is my plain old number, and so then I have to have my x's, and then I have to have my x squareds. Or I can think about my original situation and say, hey, if I'm starting out with x to the third, and I divide by x, I better start out with x squared when I get to my quotient. Right? X to the third divided by x will give me x squared. Let's try one more where we do get a remainder of 0, so we know that it works. If x minus 6 is the factor, I know the root has to be positive 6. So I see 1x to the third minus 7x squared plus 4x plus 12. So I'll use the 1, negative 7, 4, 12. I want to see if 6 indeed is a root. So I drop the 1. 6 times 1 is 6. Negative 7 plus 6 is negative 1. 6 times negative 1 is negative 6. 4 plus negative 6 is negative 2. 6 times negative 2 is negative 12. 12 plus negative 12 is 0. So there is no remainder. So I know that 6 is a root. I know that x minus 6 is a factor. And I can read the answer as 1x squared minus 1x minus 2. Right? That tells me I'm going to have 1x squared. I'm going to have negative 1x. And I'll have negative 2. Of course, I don't need to put a 1 on the x squared, nor do I need to put a 1 with my negative x, right? I could just write x squared minus x minus 2. So again, although I normally have this available as a PDF that you can just look at and not have to go through the video, if you want to go back and look at examples, I thought it might be useful to have the video available in addition to the PDF. So if you just want to quickly glance at the examples, just grab the PDF and take a quick peek at it. But if you need the explanation, hopefully you'll find that this has been relatively useful.